Alright guys, good morning. Today we're going to be talking about measuring segments and angles, and then also midpoints. So our main topic for the test today, that is going to be our learning target. So our learning target is I can apply the distance and midpoint formulas. So that's what you guys will be tested on, specifically distance and midpoint formulas, so make sure that you guys do memorize those as we work through today's lesson. So, getting started. We're just going to work on this example problem. This is from yesterday's lesson. So it's just covering some basic stuff that we covered yesterday, and it's probably similar to something that you'll see down the road. That may be a hint in itself. So, first off, we have these two symbols. This first one that we're going to see is intersection. If it doesn't look like a U, it's intersection. And then if it does look like a U, that's for union. Now, an intersection is where they cross. A union is where, or what is created. So where they cross or overlap or meet, and what is created from those two segments, or points, or rays, or whatever it may be. So, first off, our first one is dealing with an intersection. So we have the intersection of segment MP and segment PJ. Well, where do those two intersect? Right here at point P. So that'd be our answer, point P. Next, we're looking at ray PK. So I have ray starting at P, going toward K. And then we also have segment OK. So I'm starting at segment O, working my way all the way down, and then stopping at K. So again, PK continues past, OK stops at K. Looking at these, where do they overlap? Well, they start overlapping starting at P, and then they stop overlapping at K, because OK stops at K. Meanwhile, ray PK continues onwards, so only this segment is overlapping. So our answer would be segment PK. And then lastly, we finally have a union. So we're going to look for something that's created. So we're doing the union of ray HO and ray HK. So we're looking for what is being created here. Well, if we look at this, it looks like an angle is happening. So I can label this as angle H if I'd like. I can label it as angle OHJ, angle OHK, any of those backwards, any type that deals with this angle. So lots of different ways to name this angle based upon what they give us. And of course, if we have 2 points, I can use either of those points in our name as we see. All right. So let's go ahead and jump into today's lesson. So real quick, we already covered all this. And of course, this is a P. Looks like that got erased at some point, but let's continue on. So first off, distance. The distance along a line is undefined until a unit distance, such as 1 inch or 1 centimeter, is chosen. So we gotta choose the units before we can actually measure something. Now, if they don't give us units, I can always just write out units for an answer at the end. That's completely fine. But more oftentimes than not, you'll be dealing with inches and centimeters, especially if you are actually going into a career with this type of thing. In architecture or anything like that, you always want to have your units set up, and that way it's an accurate representation. Now, we can use rulers to find the distance between 2 points on a line. To do that, of course, we should know how to use a ruler, but in case we don't, I line up my ruler with the line itself, and then I have 2 numbers that are matched up with the points. Now, as long as I get one number matched up with the points, I can always just measure from that point on, and I typically start at 0 and then go on. But if I'm just in between 2 points, then I see that we have H at 4, G at 1. If I subtract these 2 numbers, 4 minus 1, that'll give us the distance between. So therefore, that distance is 3 centimeters. And that's it. That's all you have to do to measure something with a ruler. All right, next up, we got some definitions for us here. These definitions are extremely important in geometry, and we'll continue using them throughout the year. The first definition that we have is coplanar. Co meaning same, planar meaning plane. So it's points that lie on the same plane. That's what coplanar means. So anytime that I say that we have something coplanar, I'm talking about the points that are on the same plane. Next up is parallel lines, something you guys should hopefully recall from Algebra 1. Parallel lines are coplanar lines, meaning that they must be on the same plane, but they'll never intersect each other. They'll never touch. And the reason for that is that they have the same slope. If you recall back to Algebra 1, they have the same slope. If they have the same slope, then they shouldn't ever touch each other. Next is skew lines. Skew lines you probably haven't heard of before. Skew lines are non-coplanar lines, so they don't lie on the same plane, and they never intersect each other either. So they're not on the same plane and they don't intersect. So they're very similar to both coplanar and parallel lines. They have something to do with both of these. And then lastly, perpendicular lines. Oh, and sorry, you may be asking, are skew lines parallel? Well, no, skew lines are not parallel lines. They're completely different lines. Parallel lines are coplanar, skew lines are non-coplanar, and that's the big difference. Lastly, perpendicular lines. We should know this from Algebra 1 as well. Perpendicular lines are lines that intersect at 90 degrees at right angles. So those are perpendicular, meaning that they have opposite reciprocal slopes, and they'll intersect at 90 degrees. All right. Next, we have a postulate. And a postulate is just something that we can assume to be true. So our first postulate that we're covering in this class is the segment addition postulate. It's saying that if I have A, B, and C that are collinear, meaning they're all on the same line, and B is in between those other 2 points, A and C, then what we can do is we can combine segments AB and segments BC together, and if I were to combine those two segments together, what would turn out is segment AC. So the two parts are equal to the whole. Basic addition stuff. Now we can also do this with angles, so there's an angle addition postulate, where if I have two different angles, say angle 1 and angle 2, then I know that if I add angle 1 and angle 2, it'll equal the whole thing. And in this case, since this is a straight angle, or it's supposed to be, it's kind of wobbly in here, if this is a straight angle, then I know angle 1 plus angle 2 is equal to 180 degrees. So we can use angle addition postulate and segment addition postulate. Both of these are going to be used throughout the year. All right, let's move on to one of our main points of our learning target today, which is the distance formula. So the distance formula is between two separate points. So it always must deal with a line segment because it has to have a beginning and an end. It can't go on forever. It needs to be finite. So therefore, if I need to find the length of a segment, what I can use is the distance formula. So the distance formula is this formula right here, which is the square root of the difference of x values squared plus the difference of y values squared. So to do this, I'm just going to go ahead and take it piece by piece. I'd find the distance between x values, then I'd find the distance between y values. After that, I would combine them because I'm adding them together. And then lastly, I'd take the square root. Now, distance formula will always work. Distance formula came from another theorem, though, another theorem within geometry, and we can also use that theorem to help us out. Now, you guys may notice this A down here, and this B over here, and notice that we can also make a right triangle out of it. Well, that leads us to being able to use Pythagorean's theorem. So, Pythagorean's theorem is just a squared plus b squared equals c squared, where a and b are the legs of a triangle, meaning they're connected to the right angle, and then c will always be opposite the right triangle, or the right angle, sorry. C will always be opposite the right angle. So therefore, if I use this formula here, I have a squared plus b squared equals c squared. Now, the length of a is the distance between the x values. So it's just x2 minus x1, which is in the distance formula. Same with the y's. This is y2 minus y1, and that'll give me this length. So that's where the distance formula comes from. It actually comes from Pythagorean's theorem. So we can use Pythagorean's theorem to help us out. Now, if I were to solve for c, because again, I want to know what the length is, I don't want c squared, I want just c. Well, to get rid of an exponent, I'd have to take the square root of both sides. And that's what leads us to this equation right down here. C is equal to the square root of a squared plus b squared. You can always use that just to find out if you're given a triangle or if you make a triangle. However, the distance formula is still extremely important for you guys to learn as well. So let's go ahead and try out an example with this. We have these two segments. I'm going to go ahead and have two different segments here. I'm going to have my blue segment, AB. And we're just going to start with AB. For AB, I'm going to use the distance formula. And then for CD, this time through, I'm going to use Pythagorean's theorem. And this will kind of dictate that we get the same answer no matter which way we go about it. And in fact, after I use Pythagorean's theorem on CD, I'll show you another page where I have the work for this for CD using the distance formula. And you'll notice something occurred. So let's go ahead and try this out. So first thing I'm going to do is I'm going to label my points. For AB, I'm going to call A x1, so that negative 4 is x1, which means for B, the 1 is x2. Do the same thing with my y's. I have y1 and y2. From here, I can just plug them into our distance formula. Distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. Whoops. That shouldn't be a square there. That should be y2 minus y1 squared. So I just start plugging in my numbers. I have the square root of x2, well, that's 1, minus x1, well, that's negative 4, and I'm going to put parentheses around because I have two signs right next to each other, so I need parentheses in between, plus y2, which is 2, minus y1, which is 4 squared. This will give us, if I have two negatives next to each other, it turns to a plus, the square root of 1 plus 4, which is 5. This is squared here still. So I have 5 squared, plus 2 minus 4 is negative 2 squared. 5 squared will give us 25. Negative 2 squared will give us 4. So we're left with 25 plus 4, the square root of 25 plus 4, which is the square root of 29. Now, since 29 is a prime number, I cannot simplify that square root, and we're done with finding AB. This is a perfectly acceptable answer for the length of AB. Next, let's use Pythagorean's theorem to find out the length of BD, so our other segment. And then we'll compare that answer to the distance formula answer on the next page. So, what I'm going to do to use Pythagorean's theorem is the first thing I'm going to do is I'm going to draw a right triangle here. Now with this right triangle, I'm going to label one side as A, one side is B, and of course the side opposite of my right angle, the segment that we're trying to find, that's C. Now, if we notice, this segment right here, that is parallel to our y-axis. So therefore I can just count since it's parallel. So I can go, okay, well, A, this length of A is equal to 1, 2, 3, 4, 5. So A is equal to 5. Meanwhile, my B value, I'll do B in a different color, my B value is parallel to my x-axis. So I can just count on my B value as well. So starting from that right angle, I count over to our point, 1, 2. So B is equal to 2. From here, I can plug it into Pythagorean's theorem, which is, again, a squared plus b squared equals c squared, where a is 5, so I have 5 squared, b is 2, so I have 2 squared, and that's set equal to c squared. So we'll give us 25 plus 4 equals c squared. 29 equals c squared. To get rid of that square, I take the square root of both sides. We're left with c is equal to radical 29. And do you notice anything? Hopefully you're noticing that these two answers are the same exact thing. So we have the same answer regardless. Now in this method, I use Pythagorean's theorem. Would I have gotten the same exact answer if I used the distance formula for this one? Well, let's see. Looking at this, here's the distance formula with segment CD, segment CD. So if I use the distance formula for segment CD, I would have gotten the same exact answer. So both segments are the same length. That's very important for us. So that is the distance formula. Make sure that you're comfortable with the actual equation itself, and then if you're not super comfortable, get used to Pythagorean's theorem as well. Either way works. I encourage you guys to know both of them. Next up, let's talk about our second topic of our learning target, which is the midpoint formula. The midpoint formula is just the middle point. So I'm trying to find the middle point of this segment. To do that, I'm finding the average of the x values and the average of the y values. So this must be an ordered pair. This is going to be an x comma y answer. That's how these are going to be written out at the end. So I need an x value and a y value. So if I'm finding the average of the x values, I just take my x values, x1 and x2, and I add them together and divide by 2. Because there's only two numbers, so I'm finding that average. What that will do is it'll take those two numbers and it'll extend it out, and then it'll be like, okay, it's the average, so it brings it back into the middle. Same with my y values. It's saying, okay, here's the big y value, and then it averages them out, and it brings it back down. So what we're doing is we're finding that middle value with the averages. And this is the formula that you need to memorize right here. So as long as you can find that middle point using this formula, you'll be good to go. And again, that formula is parentheses, because again, it's an ordered pair. x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. And that's it. That's the midpoint formula. So again, we need to know the distance formula and the midpoint formula. Let's try one of these out to find the midpoint. So it says, prove the following statement. If jk has endpoints j at -7, -5, and k at 1, 7, then the midpoint m of segment jk lies in quadrant 2. So, first off, our quadrants, if we recall back from Algebra 1, our first quadrant is right there, second, third, and working our way around counterclockwise, fourth. So we have 4 different segments there. Now, we want to end up in quadrant 2 here. So that's the quadrant that we want to be in. So if I just eyeball these, j is at -7, -5, so it's down here. K is at 1, 7, so it's up here. We want to find out if our midpoint is somewhere in this area here. So let's go ahead and see if it is. So, to find the midpoint, I'm going to go ahead and label these x1, x2, and then y1, y2. I plug them into my midpoint formula, which is just x1, -7, plus x2, 1, divided by 2. And I do the same thing with my y values. y1, -5, plus y2, which is 7, divided by 2. I work out this answer. -7 plus 1 is -6, divided by 2 is -3. And -5 plus 7 is +2. +2 divided by 2 is +1. So our point is -3, 1, somewhere right in here. Now, is that in quadrant 2? Yes. So we can say yes, the point -3, 1 is located in quadrant 2, so M, the midpoint, lies in quadrant 2. And here's a little bit better of a drawing of it. All right, let's move on. Again, need to know midpoint, need to know distance formula. Very important for this topic today. The last thing is going to be carrying on throughout the entire year, so you're going to get used to this term quite often, and that's congruency. In the diagram below, angles A, B, and C are congruent. We write angle A is congruent to angle B, which is congruent to angle C. Now, congruency just means that they're the same exact length or the same exact degrees. So as we look at this, each of these angles is 50 degrees. And that's why I can say it's congruent. Now, they also have this little purple mark on each of them. What we call those are congruency marks, or tick marks. You guys are going to hear that term quite a bit, and what those tick marks tell us is that they're the same. So even if I didn't have a number here, or here, or here, I'd be able to tell that these 3 angles are all congruent to each other. They're all the same. Now, if I only have one number, but I don't have it for the other 2 angles, so these 2 angles are still blank, but I have 50 degrees over here now, then obviously I can say, okay, well, this angle's 50 and this angle's 50 because they all have the same congruency mark. Now, if I have another angle that's 40 and a second angle that's 40, I can't give those the same congruency mark as we have up above. I can't give it 1 congruency mark. I'd have to give it 2 congruency marks or change my symbols up just a little bit. So that's how you can go through these. That's what congruency is, and you're just matching. If they have 2 together, they're the same. If they have 1 together, they're all the same. So that's how we go through this. And again, congruent angles are angles that have the same measure. This symbol is our congruency symbol, so make sure that you get used to it. It's just an equal sign with a squiggly line over the top. That's how you'll be able to always tell that something is congruent. Now, we can also use congruency with segments as well. Angles aren't the only thing that can be congruent. Segments can be as well. Same type of thing going on with segments. As you can see, these are all 3 centimeters, so they all get 1 congruency tick mark. If I had 2 more segments down here, let's say that these are both 5 centimeters. Well, then I know that these two segments aren't congruent to the other ones up top, but they're congruent to each other. So therefore, they would get 2 congruency tick marks to show that they're congruent as well. So again, 2 goes with 2, so they're the same. 1 goes with 1 goes with 1, so they're all the same. So again, that's how you guys will be able to tell just by looking at the congruency marks what's the same, what's different in these diagrams. All right, that's it for congruency. Or sorry, let's go ahead and try a practice activity with congruency. So to prove congruency, we use identical tick marks, as I said earlier, or congruency marks. Those terms are interchangeable. In this diagram, what I'd like you to do is go ahead and pause the video for a second if you'd like, and name the 4 pairs of congruent parts in these 3 diagrams here. So I want to know what's all congruent. All right, so as we were looking at this, we can see that angle K has the same congruency tick mark as angle T. So I can say angle K is congruent to angle T. Same with GH, segment GH and segment SR. I can say GH is congruent to segment SR, or I can write them backwards if I'd like. Lots of different ways to write these, so that's okay. And then for our last figure, this isosceles trapezoid over here, I can say angle W is congruent to angle X. And I can also say segment ZW is congruent to segment YX. Because again, 2 congruency tick marks together, and then 1 angle mark and 1 angle mark. So that's how you can go through labeling, and then of course this is our correct notation when we're saying that 2 things are congruent to each other. Very important that you guys get congruency down because they'll be used throughout the year. Lastly, our last practice problem. So use the marks on the diagram to determine the measure of angle EBC. So looking at this, from our first lesson, I know that if I have a straight line, I can assume that this is a straight angle, meaning it's 180 degrees right away. Also, if I see a box, I know a box is 90 degrees because that's our right angles as we learned yesterday. And then do we see any congruent angles here? Well, yes. I see this angle is congruent to this angle, which is congruent to this angle. So these 3 angles are all congruent. I'll go ahead and give them a variable. Let's give it the variable x. So now I have 3x, because there's 3 of those angles, plus 90 degrees is equal to the whole thing, which is 180 degrees. So we'll give us, if I subtract 90 from both sides, so we'll give us 3x is equal to 90. And if I divide both sides by 3, we're left with x is equal to 30. But that's not what they're asking for. They're not asking for x. They're asking for the measure of angle EBC. So EBC is this big angle right here, this green angle. So that's what EBC is. So I know that this angle up top here, this red angle right here, I know that that's 30 degrees. I also still know that this is 90. So the measure of angle EBC should be equal to 30 degrees plus 90 degrees, which of course is 120 degrees. And that's our final answer. Now in this, of course, I just changed the x to angles. You can do that if you'd like, but I encourage you guys to get used to using x's and different variables as well in there. All right, so that covers our lesson for today. You guys now know distance formula and midpoint formulas. That's what you guys will be tested on, so make sure that you guys are comfortable with those and that you memorize those. Your homework assignment today is homework 1.1, Introduction to Geometry. That's in Schoology. You should be able to start working on that today. That will be due Friday. If you guys have any questions for me, please let me know. Other than that, I hope that you guys all have a great day. Thanks for stopping in.